All right, from thermal physics, one of my favorite topics is temperature scales also. Remember in the last lecture, I was telling you that in science, nothing is abstract. Everything has to be there in a way that you can measure it. Okay, so with thermal physics, once you understand the basics of thermal physics and we read that temperature is there, a very important question arises that if temperature is also, because if we are studying it in science, then temperature could also be something that we can measure, right? It cannot be just an average concept that we are giving out in an abstract manner. So how do we measure temperature? Because we can't see the particles directly, we cannot see them moving. For the measurement of temperature, remember that there is, let me use a different colored pen, physical property of a substance, and I'll explain it in a bit. Physical property of a substance changes with the change in temperature. So what I'm trying to tell over here, that temperature, number of particles, kinetic energy, that's something we can't see, we can't measure. Then how do we measure temperature? In every kind of material, there is some physical property which changes as the temperature changes. Okay, that physical property is something that we can measure, right? So when we can measure a physical property, we relate it to like, or you can say we convert it into temperature language later on. First we understand what is changing with temperature, and these physical properties have to be very sensitive so that they can uh, measure or they can change on every temperature change. For example, the thermometer that we all see, the thermometer has mercury in it. Okay, mercury as a fluid is present in a thermometer. If on every 1 degree Celsius change, this mercury fluid does not expand, then you won't be able to measure temperature properly, which suggests that mercury has a property, physical property, that is sensitive to temperature change. As soon as the temperature increases or decreases, it's going to expand or compress, which tells you, okay, temperature is changing. So first we measure that physical property and then we talk about that physical property in terms of temperature or the scale or anything. That physical property is called thermometric property. This physical property is called thermometric property. Thermometric property. So thermometric property is something which changes. We cannot, like we can, um, it's just a measurable property that is changing with temperature and we measure that. So it's an indicator because we cannot directly see temperature, but we can observe something that responds to it. Remember the word observe, that something is changing that we are observing. All right. What about mercury? Mercury, it's expanding. But what is expanding over here? Because we should be able to name that property. So first property that's very common is density of a liquid. Density of a liquid. So when most liquids are heated, they expand. Many liquids, when they are heated, they expand. Their volume increases, even though the mass is same. Mass is not changing. You've already put the mass over here. It's just expanding. You can think of a balloon. Okay, when you inhale air into the balloon, it's going to grow in size. Is the original weight of the original mass of the balloon changing? No, it's just growing in size. In the same way, when we think about this liquid which is expanding, volume increases but mass doesn't increase. As a result, what happens? That density decreases. So, just in like straightforward words, density changes with temperature. Density changes with temperature. So, this is the first thermometric property. Second is volume of a gas. Volume of a gas. And if volume is changing, then we are going to keep pressure constant. Constant pressure. Because pressure also has uh, that ability to change the volume. That is why we have to keep the pressure constant, so that when we are measuring the temperature, pressure should not be interfering with it. I hope this point is clear why pressure has to be kept constant. So when you heat a gas, while keeping the pressure constant, the gas is going to expand. Its volume increases. That increase can be used to indicate temperature as well. All right. Third one is electrical resistance of a metal. This is a very important property. Electrical resistance of a metal. It also changes. Resistance of a metal, I think you've already studied also, that when the electrical energy is flowing, the electrons are moving for the electricity to be transferred. The original particles of the metal sometimes provide some hindrance to those particles, which we call it resistance. Okay. So as temperature increases, the metal atoms vibrate more. Okay, so first of all, think of the metal which is just over there. It's a conductor of electricity. Some particles are colliding with the particles of a metal, and resistance is provided by the metal, but others are moving uh, easily. Whereas now, if you increase the temperature of that metal, the metal atoms vibrate more. Electrons collide with them more often. When electrons collide with them more often, electrical resistance increases. Because before, metal atoms were vibrating, but they were vibrating at a very fixed position and a very fixed rate. But as you increase the energy, the metal atoms become more, what do you call it? They vibrate more, they become more restless and everything, so electrical resistance increases. And this principle is used in resistance temperature detectors, RTDs. Resistance temperature detectors, I think you can write the full form yourself also. Fourth is EMF of a thermocouple. All of these are very important, make sure you memorize all of them. EMF of a thermocouple. EMF of a thermocouple. A thermocouple, first of all, to understand what is a thermocouple consists of two different metals joined together. Two different metals joined together. When okay, when the junctions are at different temperatures, a voltage is produced. Okay, so the junctions have to be at different temperatures. The larger the temperature difference, the larger the EMF is produced. This is useful in measuring the very high temperatures where ordinary thermometers may not work. Okay, because EMF is changing, more voltage is produced. More voltage is something which will indicate a larger change in temperature also. So very high temperatures uh, which we can't measure by using the normal thermometers, we measure them using EMF of a thermocouple. Now, all of these were different thermometric properties, but as I was telling you, that these thermometric properties have to be changed into temperature language. Temperature language means that you should be able to talk about them in terms of temperature. You should be able to define them in terms of temperature. So, different thermometers use different thermometric properties. A mercury thermometer uses expansion of a liquid, as I was already telling you. An RTD uses uh, re- resistance. A thermocouple uses EMF. Since these properties don't all change in exactly the same way, because all of them are different, right? In some of them liquid is expanding, in some of them gas is expanding. Third one has resistance in it. Fourth one has EMF. All four properties are different, and all properties are not going to change in the same way. So we have to give them one scale. We have to convert them into one specific temperature language in which we can at least define temperature. So to avoid depending on any particular material or property, physicists use the thermodynamic temperature scale, which is called Kelvin. Kelvin is that temperature language. The Kelvin scale is based on fundamental physics laws, not on the behavior of a specific substance. And there are some conversions that you need to know for your syllabus. Water freezes before the conversions. Okay, let's just give you the conversions first because I said that. So if temperature is in Kelvin, you can, like, if temperature is given to you in degree Celsius, you can convert it into Kelvin by adding 273.15 to it. And if you have to calculate degree Celsius temperature From the, I am sure I'm putting it wrong. This time Kelvin would be given to you. All you have to do, subtract 273.15. Never write degree Kelvin, because Kelvin is always written alone, but only with Celsius we write degree. Then comes another very important concept, which is absolute zero. Absolute zero. The lowest possible temperature to exist is called absolute zero. Okay. At absolute zero, the particles have the minimum possible internal energy. Classical physicists would say particle motion stops, but quantum mechanics now tells us that particles still possess a tiny amount of unavoidable energy, which we call 0 point energy. 0 point energy. And for your syllabus, you just have to remember that it's sufficient to know that 0 Kelvin is the lowest possible temperature and no temperature below it exists. That's all that you need to know. If you understand properly the definitions of thermal physics and temperatures and thermodynamic properties and everything, then you will be able to understand ideal gases, thermodynamics, any other concept linked with thermal physics. But make sure that you start with the basic definitions, and then you understand how is how temperature came into existence. So temperature has already been defined, but first we see which physical property can change with the change in the temperature, so that we can equate that physical property in terms of temperature. How to equate that in terms of temperature, that's not part of any syllabus at IGCSE or A levels, so you don't need to learn that. But you should just remember that a thermometric property is used to equate it to Kelvin and to measure the temperature. So it was this was it from so far the syllabus. Other concepts of thermal physics would be discussed in the next lectures. Thank you. Bye. And if you have any questions, let me know.